Ah, there we go. This short video is going to be talking about molar ratios and how to find them and discover them. So let me get to a pen and here, excuse me, here we go. And there's my pen. So molar ratios, what we're looking at, that's the definition. And the definition is the mole ratio is a ratio of compounds to another compound in balanced chemical equation. And we use these mole ratios to basically figure out how much stuff we need or how much we're going to be made. And it's all based on a balanced chemical equation. This is why we have you guys balance those equations before. Now, for example, and you notice I have the mole ratios down. With this reaction, we have 4 molecules or moles of NH3 plus 6 moles of NO. And we end up producing 5 moles of N2 and 6 moles of H2O. So whenever we have this reaction, 4 of these must react with 6 of these to produce this and no other. If I have 5 molecules of NO, we're not going to have the reaction because you need 6. And so this is the ratio, the reaction that occurs. Now if I have 4, so if I take NH3, put it on the top, it's related to 6 NOs. And here's my mole ratio. It's just a relationship in the balanced equation. If I have 4 of these, I'm going to be using up 6 of these. 4 of these, 6 of these. If I have 4 of these, I'm going to make 5 of these. And this is what we're doing here. There's my 5, and there's my 4. So 4 to 5. And guess what? We can also write it as 5N2 over 4NH3. Either way, it's still a molar ratio. And we're going to be using this a lot in helping us solve some chemical problems. And this is what this slide and the assignments embedded in this slide and things we're going to be doing this week all involve using these. So when I taught this when we had at school, I asked you guys to do this. So let's find the mole ratios for the following reactions. So I'm looking for how many. I have 1 Sb to S3, and the relationship with ion is 1 to 3. So I got 3 Fe on the bottom. And this is how this works. So I also can have 3 Fe to 1 Sb to S3. Now, you don't have to put the 1. You can put a 1 here, but you don't have to. Because if there's nothing in front of it, you assume you have 1. Because if you have none, it's not going to be there. So let's go this way. We have 3 iron, and we're going to end up making 2 Sbs, antimonies. So every 3 ions we have, we're going to end up producing 2 of these. And look, let's look at, we've got 3 iron sulfides made. To make those, we have to have 3 ions. You can use a 3 to 3, or you can go 1 to 1. It doesn't matter because basically these are the same ratios. So these are some of the mole ratios you can find in a reaction. There's a few more in there. You could probably come up with a few more. But they're basically will equal. And if you write this another way, come on, pen, where'd you go? So if we come down here, we have Sb2, S3 is equal to 2 Sb. In this reaction, this forms this, or Sb2S3 is equal to 3 Fe. And this is all true because this is what this reaction tells us. It's all based on this chemical reaction. So this must be balanced before you do this. So in any given reaction, we want to figure out how many moles of a compound. And once you know given the chemical equation of moles of one compound, you can determine everything else that we have or need given the reaction. So when we look at this, we have, and this is the balanced reaction, but we're given 1.36 moles of Fe. how much of this do we need? So we write this down. I'm going to go down here. So 1.36 moles of Fe. I forgot the mole. Over 1. And I want to multiply that by the molar ratio. And we need Sp2. So we're looking for how much Sp2S3. So Sp2S3. And it's a 1-to-1 relationship. We got one mole of Sp2S3. Now we got 3 moles of Fe. Now we could do Fe's cancel. And you take 1.36 and you divide by 3. And you get 0.453 moles of Sp2S3. I want to point out, guys, when you're doing this, do not cross more. We're crossing out, but I don't go 1.36 times 3. There's a small error people are doing this, and please don't. Remember, these are, you multiply the top, multiply everything on the bottom, so you got, and then you divide. So we still have 1.36 moles of Fe, and we can finally figure out how many SPs we have. And I'm going to come up here because I know I didn't give myself space on the last slide. So we have 1.36 moles of Fe. And for every 3 moles of Fe, we have 2 moles of Sp. And you times 2, and divide by 3, and we got 0.906 moles of Sp, of antimony. And that's how you work on these things. Now here's another reaction for you guys. We have 4 aluminums, 3 moles of O2 to make 2 moles of A2O3. So we need to make 4.2 moles of aluminum oxide. How many moles of that are we going to make? So the molar ratio, we need to get rid of moles of aluminum oxide, which is Al2O3, excuse me, and we just need Al, and that is a 4. So 4 moles of Al will produce 2 moles of Al2O3. So when we do this, we should end up with 8.4 moles of aluminum as part of our product. As part of what we need to use to make that much product.